Okay, show that S equals ut plus a half at squared. The starting point for this derivation is to consider the motion of an object. Let's draw a little graph. This object starts from some initial velocity u and increases its speed to some final velocity v. So we've got u as the starting speed, v is the final speed, and this whole process takes a time of t seconds. So the displacement s equals the area under a velocity time graph. So s equals the area under the graph. Now the area under this graph is a quadrilateral, but we need to get nice easy shapes to work with, so I'm going to divide it into two bits. I'm going to divide it into a rectangle, which I'm going to call area 1, and a triangle, which I'm going to call area 2. Okay, now let's consider area 1. The area of 1, it's a rectangle, so it's the length times the breadth, so the length is t times the breadth, which is u. So the area of that rectangle is tu, and since we know that t times u is the same thing as u times t, I'm going to call it ut. Okay, now area 2. Area 2 is a triangle, which is a half the base times the height, so it's a half times the base, which is still t, times the height, which in this case is the final speed, take away the initial speed, which is v minus u. Now, we know from earlier on that a equals v minus u over t, therefore v minus u equals a times t. So this v minus u here can be replaced by a times t. So that gives us a half times t times a times t, which is a half a t squared. So the total displacement S equals area 1 plus area 2 equals ut plus a half a t squared. S equals ut plus a half a t squared. That is what we started out to show.